Welcome to this office mix for the Our Dynamic Universe unit of hire, looking at forces and connected systems. So what are we looking at here? Well, we're looking at how to carry out calculations using Newton's second law, F equals ma, in situations where objects are connected. So this could be a car pulling a trailer or things that are touching, as we'll see. So here's our first example. We've got three identical trolleys connected together by string, and we're pulling them along with a force. And our question is to, assuming there's no friction, calculate the acceleration and what is the tension force in each piece of string. So to calculate the acceleration, we need to treat the whole system. So the force applied to the whole system is 12 newtons, and that's the unbalanced force because there is no friction in this case. The mass of the whole system is 2 plus 2 plus 2, which is 6 kilograms. So this means all of the objects, because they're all tied together, will have an acceleration of 2 meters per second squared. So now we need to work out the tension in each string. Well, the tension in string 1 here, well, that is just pulling the second one of 2 kilograms, and it needs to have an unbalanced force of equal sufficient force to accelerate it at 2 meters per second squared. So that means that the mass of 2 times the acceleration of 2 means that there must be 4 newtons acting at that point. If we look at trolley number 2, T2, the bit of string 2, well, again, the tension equals the mass times the acceleration, but this time we've got 2 trolleys being pulled by that piece of string, so we've got a mass of 4, but we have the same acceleration of 2, so we have 8 newtons here. If we looked at the 12 there, if we didn't know that was 12, then we could say the same thing. We've got 3 trolleys, so that would make 6, and 6 times 2 makes our 12 newtons from there. Okay, let's look at some touching objects. So we've got 2 blocks here. We push one, we want to know what the acceleration of the system is. So we're given information here. Now there is some friction between the blocks and the floor, and then we're going to work out what the force of the 2 kilogram block on the 10 kilogram block is. Okay, so they're pushed. Okay, so the first thing we do is take the system as a whole. So the whole system there has a mass of 12 kilograms. The unbalanced force is 20 minus 7 minus 7, which gives us 6 newtons. So 6 newtons is equal to our mass 12 times the acceleration a. This means we get an acceleration of 0.5 meters per second squared for the whole system, because they're all going to move together. The force exerted by the 10 kilogram block on the 2 kilogram block, well, we're looking at what is accelerating, and we're going to use that mass. So what's accelerating is the 2 kilogram block, and we said it's accelerating at half a meters per second squared from earlier. So that exerts a force of 1 newton on that. Okay, here's a question for you to try. Okay, you should now pause the video, try and work out your answers before I write them down for you. Okay, if we look at part 1, what's the acceleration of the block? So treat the system as a whole. So the total mass is 8 plus 8 plus 8 is 24 kilograms. The unbalanced force is going to be the pushing force, 60, minus the friction, which is 4 on one, 4 on the other one, 4 on the other one, because there's 3 blocks. So 60 minus 12 is 48 newtons. That means our acceleration is the unbalanced force divided by the mass. 48 divided by 24 equals 2 meters per second squared. Did you get that answer? Okay, now pause the video if you need to work out part 2. Okay, so now you're going to work out the force that block A exerts on block B. So you're looking at what's moving there. So this time it's these bits that are moving from there. So that means that you're taking your acceleration and you're working out your mass. So we're going to use Newton's second law, F equals ma, and we need to take the mass of the two, so it's 16 times the acceleration, which gives us 32 newtons. The force that block B exerts on C is done in the same way, F equals ma. This time there's only one block at the end, C, so we're going to take 8 times 2 to give us 16 newtons of force. Okay, here's a problem looking at strings. Okay, if you pause the video, you can work out the answer. So here's the answer for you. So to work out the acceleration, you take the system as a whole. So the acceleration is F over m. There's no friction, so the unbalanced force is 24 newtons, and the mass of the whole system is 3, so that gives us 8 meters per second squared acceleration. The tension in the string is equal to the mass times the acceleration, so that is the mass of what is getting pulled, 2 times the acceleration of the whole lot, 8 meters per second squared is 16 newtons. Okay, you should carry on and work out the next of the calculations. Okay, we're now going to look at slightly more complicated systems. Let's look at the system shown. We're going to work out the acceleration and the tension in the string. And this time we've got something hanging off the edge. Okay, so for the system shown, calculate the acceleration and the tension in the system. In this example, both objects have the same acceleration because they're joined together by the piece of string. If we look at the block at the bottom, then the unbalanced force downwards on the block is the difference between the weight down and the tension upwards. So the mass times acceleration, because F equals ma, is equal to m times g minus the tension. We know that the mass is 2 and the acceleration a, and we can put 2 times 9.8 because we know the mass minus the tension. So we end up with a problem at the bottom. 2a equals 19.6 minus t. To work out the acceleration, we need to look at the tension, which we then need to consider the other block. So by considering the other block, the tension equals the mass times the acceleration, and the tension is 3 times a. So from earlier, our relationship 19.6 minus t equals 2a. We've now got that t is 3a. So we get 19.6 minus 3a equals 2a. If we move across the 3a, we end up with 19.6 is 5a, and we work out the acceleration 3.9 meters per second squared. Okay, here are some more examples that you should try based on the same type of problems as the example before. And here is another one too. So complete these questions to show that you've got a good understanding of this type of problem.